Okay, we're live right now. All right, who is the first guy that joined? You're welcome. Tell your friends, let them join in this chat. Okay. Badrick. Finally. All right, if ready, I'm with it. Tell them you're live now. They should join it then. They shouldn't make it slow like it did yesterday. Okay, I need like 20 people to be here, then we can begin. And if you think there are some special questions we should look at, kindly say it in the comment section. I'll look for that and then make sure we do that. All right, these are the questions that I have. It involves the units 1, 2, 3, and unit 6 as well. All right, so the thing is, Dr. Ambafu usually will give you some general questions, and then he will bring similar ones, but some different questions, right? Similar question. That's the best way. Similar question, and we'll change some things that if you understand the concept, you can be able to apply there. So that's what's going to happen. I can walk on water. Don't let me down. I know you won't. that boy? Don't know. At last we are here. Let's have some fun, Van Dyke. Tell your friends we are waiting for them. Oh. Yesterday they blocked my videos with it. We have 4 people. Come on, guys. All right. By 6:20 we go. All right. Which part do you have on Monday? The mechanical, please. Van Dyke, which part do you have on Monday? Oh, where is Don? Don. Oh, okay. Let's run this quick. Hey, a lot. Okay. Let's hope. Maybe end of SEM. I'll do this for automatic controls. For numerical, there are, in fact, controls. There are a lot of videos here. There's this Indian lady that teaches the controls very well, and then she solves questions too. Yeah, so for that, I mean, people are doing it. Unlike this one, that there aren't more videos on it. Badrick and Van Dyke, I hope you guys stay with me throughout. I don't want you guys to leave. Yeah, that Indian lady, she is very good. Yeah, I mean, I did controls 1 and 2, and she was the one I used, honestly. Yeah, she is very good. But you know, yes, I definitely have to do one that, I mean, with this kind of tone, our own language, you know. Maybe. Okay, sure. You can always come back and watch, so don't worry. Yeah. Three minutes more and we take off. Is the one who teaches on the whiteboard. Yeah, that lady. They're actually a team, and she's just one of them. One minute more. Yeah, and his videos, if you check her videos, after every topic there are sample problems, you understand? So after watching the video, then you solve the questions. I mean, he's using the same book that the lecturers use. I think Ogata. Yeah, I have that book. If after I have there is this Telegram channel in the video, the subscription, you can join and then text me if you want their controls book. There is this book that they all use. The lady uses that, the lecturers use the same book, Ogata. Controls actually interesting. Okay, 6:20 on the dots. Thank God for our fire has brought us. We begin. Okay, so we are going to start with the unit 2 questions. These two, I solved them yesterday, so I wouldn't go back to them. So let's start with the first one. Okay, so this is a moment of inertia question. Right now, the question is asking us to find the mass moment of inertia of the rod about the x-axis, about the y-axis, about the z-axis. Okay, there is a similar question that is a bench rod, but different form like this. And that one came in the mid-sem and end of sem. I mean the last years, your seniors. I don't know what could probably happen, right? But it's going to be similar concepts. So you try as much as possible to understand this. If you have a question, you ask. If you finish and you have the time, I will try and bring that up and we see how that goes. As my boys, I beg, stay with me. Hold tight and let's roll. Okay, so there's a bench rod, and then this is the origin, right? This is the origin, the O. We are looking for moment of inertia about the x-axis. So let me give a brief knowledge here. If you are finding the moment of inertia, so let me say for a rod or a slender rod, if you want to find moment of inertia about an axis passing through its longitudinal direction, so along the length, the axis passing through along the length, the moment of inertia about it is 0, right? So if here is x, then ix will be 0. Alright, Nike, I'll send it to you. If here is z, then iz about the center of the object is 0, and if here is y, iy about the center is what? 0. And then the rest. So suppose here is y and here is x, here is z, then ix will be equal to iz, which is 1 over 12 ml squared, and iy will be 0. Now suppose you are finding the moment of inertia of this rod about a different axis, then maybe we want, so maybe iz is here. So if you want, let's say this is d, if you want iz, that will be I about the center plus md squared, and this d is the distance between the z-axis here and the z-axis that find the moment of inertia about. All right, so with this out of the way, with this basic knowledge, let's see how we go about this. So here we have a rod that has a uniform length of 4b and a total mass m. All right, so the total mass of the rod, total mass is 4b, and the total length is what? Sorry, total mass is m, and total length is 4b. Okay, so if we want the density, all right, now you need to find the mass of the, okay, so there's a thing. We are going to put the rod into components. You see it's bent, so we are going to cut them into straight parts. So we'll have part AB, maybe part BO, part OC, and part what? OD, giving us 4 parts. So we would want to find the mass of each part. Now because the rod is slender, we can't find the volumetric density, and it's not a plate, so we can't find area density. What we can find is linear density, and linear density is equal to mass over length. So in the case where the total mass is m and total length is 4b, density is going to be m over 4b. All right, and you have this as a density. So if I want the mass of AB, so let's say mass AB, you realize that from here to here the length is b, so it's going to be what? Rho times length. I mean mass over length is density, so density times length will give us the mass. Now rho is m over 4b and the length of what AB is B, and that's going to give us what mass over 4. So realize that they are all having length B, B, B. So all of them are going to have what mass m over 4. So you know the mass for all of them. In exams, it will be more appropriate to say that MAB is equal to MBO is equal to MOC is equal to MCD is equal to M over 4. So that if they're going to be marked for finding the masses of the individual parts, you can be given over here. The next is to go ahead to find our moment of inertia. So I'm going to find the moment of inertia about the x-axis. So what I'm going to do is that I'm going to pick the parts one by one and then locate their centers and see how we can relate their centers to the reference points given. Let me drag that down. Okay, so for IXX, as stated earlier, if I pick the block AB, its center is somewhere here, so its X will be along the longitudinal, its Y will be along this direction, the Z will be along this direction, and then the Y will be here. So Y here, small z here, small x here. Alright, so if I want IXX, it will be equal to the IX about the center of AB plus the mass AB and the distance between this X and this X. So the thing is, the moment of inertia about the X of the rod, we are going to find all of them and add. So let me say IXX will be equal to IXX AB plus IXX BC plus BO IXX OC plus IXX CD. So IXX AB is what I was doing earlier. Moment of inertia about its center plus MD squared. Now you can see clearly that the X passes through the longitudinal part of the AB, so its IG is going to be 0. Then the mass is m over 4. The distance between this X and this S, we start from here coming down, so that would be negative what? B. So you have negative B all squared, and you're going to have MB squared over 4. Okay, then we find IXXBO. IXXBO will be IG plus MD squared. I have to indicate that this is for BO and not that, but at least you know from here. So if we pick BO, let me clean the other one. If I pick BO, its X will be here, its Y will be here, and its Z will be here. So about the center IXX, we are going to have 1 over 12 ML squared plus MD squared. So the mass, so 1 over 12, the mass is M on 4, the length is B all squared plus M on 4 B squared, and this one will be MB squared over 48 plus MB squared over 4, and this simplifies to now be 13 on 48 MB squared. Then we go ahead to find IXX OC. So IXX OC So IXXOC is the same as IXXBO. Alright, the same x here, and you have 12ml squared plus mb squared. So I'm just going to say IXXOC is equal to IXXBO, which is equal to 13 on 48 mb squared. Okay, so with that out of the way, we move to IXXCD. So for CD, its center is somewhere here, right? So I should go. Now you realize that this x and this x, the distance is slanted, right? So this d squared is equal to from here to here squared plus from here to here squared. So we're going to have, let me do that here. So IXX CD will be equal to 12 LM squared plus MD squared on 12. The mass is M on 4. The length is B all squared plus M on 4. And the D is what? B over 2 all squared plus B squared. Okay, so B over 2 all squared plus B squared will be equal to the D squared, the distance between this X and this X. So if we do that, if we simplify, we have MB squared M over here. I made a mistake here, so it's supposed to be B. So MB squared here. So MB squared over 48 plus, so here I'm going to have MB squared over this 416 plus MB squared over 4. So I have 48 here, MB squared plus 3MB squared plus 12MB squared, and this will give us 16MB squared all on what? 48, and that will be MB squared on 3. So your IXX will be equal to the first one, MB squared on 4 plus 2 times 13 over 48 MB squared plus MB squared on 3. This is 2 because this and this are the same, so I multiply this by 2, I get this. Then we simplify. So IXX will be MB squared on 4 plus 26 on 48 MB squared, or let me use 16 MB squared on 48. So IXX will be, so LCM is 48 now. We have 12 MB squared plus 26 MB squared plus 16 MB squared. So IXX gives us so 42.54 on 48 MB squared kilogram meter square. Okay, so that is for the IXX. Now I move on to the IYY. If you have a question, let me know. Okay, so for IYY, same approach. You pick this. So IYY2 will be equal to IYY AB plus IYY BO plus IYY OC plus IYY CD. Alright, so IYY AB will be equal to, so if you pick this, the center here, y is not along the longitude now, so I'm going to have 1/12 ml squared plus md squared. The distance between this y and this y is just what? Half b. So we're going to have 1/12, the mass is m on 4, and the length is b all squared plus m on 4, and the d is b on 2 all squared. Don't forget, this m and this m are not the m's we are using here. We had a m in the question, this m, that is what we are using. This is just general formula, and this m is the one that is given in the question. So we are going to have m squared, mb squared over 48 plus mb squared over 16, and that will be, so I think 134 over 48 mb squared equals mb squared on 12. Then we do for BO. So IYYBO, the center is here, and then this is the y-axis, right? So the y-axis is passing through the length of BO, so this part is going to be 0. So it's going to be 0 plus md squared, and the mass is m on 4. The d, the distance between the y passing through this one center and the y-axis is also what? 0. So 0 squared, and it's going to be 0. So IYYBO is equal to IYYOC equals 0. Of course, the rod is lying on the y-axis, right? And we said it was moment of inertia of about the axis passing through the longitudinal is 0. So yes, that is not a miracle. So the next is the CD. So IYYCD. Realize that we have y here, and the distance between this y is from here to here. So I'm going to have 1/12 ml squared plus mb squared. Now m obviously is m on 4, length b squared plus m on 4, and then, sorry, I made it b, supposed to be d. The distance between the two y-axis is b on 2 all squared, and this gives us mb squared on 48 plus mb squared on 16, and that will be 4 on 48 mb squared, which is equal to 1 on 12 mb squared. So the total IYY will be equal to 1 on 12 mb squared plus 0 plus 0 plus 1 on 12 mb squared, and that will be 1 on 6 mb squared. Okay, and then IZZ, that's the last one. Let's bring this guy down. Okay, so the next is IZZ. I find the moment of inertia of this rod about the z-axis. All right, about the z-axis. So we're going to pick them one by one like we did. Wait. Okay, so if you pick block AB, the z-axis is here, so the z-axis is also what's not is transversal, it's not longitudinal. So IZZ, obviously are going to have IZZ AB plus IZZ BO plus IZZ OC, sorry, plus IZZ CD. So IZZ AB are going to have 1 on 12 ml squared plus md squared. 1 on 12, the mass is m on 4, the length is b squared plus m on 4, and the d, which is the distance between the z here and the z here. So realize that that's going to be what, a slant line. So the d here is going to be d squared, is going to be b on 2 here and what, b here. So I'm going to have b on 2 all squared plus b squared. So that will be mb squared on 48 plus mb squared on 16 plus mb squared on 4. So we have the LCM 48, so mb squared here plus 3 mb squared plus 12 mb squared, and that will be 16 1 on 3 mb squared. Then we do for how do you call BO. So for BO, which is from here to here, HZ will be here. So the sum between this, you just have B. So IZZ BO will be 1 on 12 m on 4 b squared plus md squared, but the d this time is b on 2, so m on 4 times b on 2 all squared, and that gives us mb squared on 48 plus mb squared on 16, and that will be, so 48 3 4 mb squared on 48, giving you mb squared on 12, and that is the same as IZZOC. Okay, so last one, which is IZZ CD. So for the CD, the z-axis is along the what, along the longitudinal section. So IZZ CD, you have 0 plus md squared. Now 0 plus the mass is m on 4, obviously the distance d between this z and this z is here, which is b. So we have, so IZZCD will be what, mb squared on 4. So our total IZZ are going to have 1/3 mb squared plus mb squared on 4 mb squared on 12 times 2 plus mb squared on 4. This is 2 because from here to here it is the same as from here to here. So we found this, what is this, and then multiply by 2. So that gives us 1 over 3 mb squared plus mb squared over 6 plus mb squared over 4. So we have 12. We have 4 mb squared plus 2 mb squared plus 3 mb squared. If you add all of them, that gives us 9. So we're going to have 9 on 12 mb squared, which is 3 on 4 mb squared, and that will be IZC. Okay, so our total moment of inertia about the z-axis will be this. Total moment of inertia about the y-axis will be this, and about the x-axis will be this. I mean, this we can further break this one down to something easier or simpler. Okay, so that is that for question 1. Any question before I move to the next, please? Any question? Badrick, are you here? Yeah, so you have any question, or we should move on, Badrick? And the rest of you, please. All right. So the next is this problem. Okay, so this question I'm going to make it very simple. So the moment of inertia of any of them, each of them is a cylinder, right? Each of them is a hollow cylinder that has been sectioned. So the moment of inertia The moment of inertia for each of them is going to be rho pi h on 2 big R power 4 minus small r power 4, and the mass of each is going to be rho pi h r squared minus what is. The question they're asking us is to find what's the radius of gyration, and r is equal to, radius of gyration is k. So k is equal to square root of total I all over total m. So that's basically it. So if I pick this, so the first one, the one with height 10 millimeters, so this one, right? So let me label them 1, 2, 3, and 4. So for one, it is a fiber reinforced polycarbonate, and this is the density. So for I for one is going to be rho pi h1 all on 2 big R for 1 power 4 minus small r for 1 power 4. So rho obviously is 1250. The h is 10 millimeters, which is equal to 0.01 meters. Big R for 1 is going to be, so the diameter for the big R is the distance from here to here. That's the diameter. So if you divide by 2, that gives us what the radius. 34 on 2 is 17. So we have 17 mm, and that is equal to 0.17. 2, 3, so 0.017 meters. Small r for 1 will be, so the small r will be from here to here. That's the diameter for the inner circle. So if we divide by 2, we get 14, and that will be 0.014. So I for 1 will be 1250 times pi all on 2 multiplying the h 0.01 into brackets 0.017 power 4 and 0.014 power 4. So I for 1 will be so 1250 multiplying pi shifts, and we have h, which is 0.01 all on 2 multiplying 0.017 exponent 4 minus 0.014 exponent 4. Okay, so we have 8.85 times 10. So 1, 2, 3, 4, 5, 6, 7 times 10 power minus 7. Okay, then we do for I for part 2. Oh, come on. Yeah. Okay, so for part 2 we have the height to be 4 millimeters, and then the radius, we have the 28 as the bigger radius now, and this. So I for 2 I'm going to have, and the mass is, the density is the same, so 1250 on 2 pi multiplying the height now is 0.004, and then the bigger radius we have 0.014 square power 4 minus 0.0075 power 4. This is 15. Oh, that is 22 rather, so that would be 0.011. So 22 on 2 11 1 2 3 0 1 1 power 4, and I2 will be, so 1250 on 2 multiplying pi multiplying 0.004 multiplying 0.014 power 4 minus 0.011 power 4. Okay, so we have 1 2 3 4 5 6, so 1.867 times 10 power negative 7, and then I3, for I3 we have same 1250 times pi times the height now is from here to here, which is 0.018 multiplying, okay, all on 2 here, and then the big R is going to be 22, the smaller is 15, so we have 22 on 2 is 11, 0.011 power 4 minus 0.0075 power 4. So I3 becomes 0.00018 0.11 7 5. Okay, so we have 4.05 times 10 power minus 7 kilogram meter square. Then we do for I4. This time the density is what for brass, and the brass density is 8650. All right, so I'm going to have 8650 on 2 multiplying pi multiplying the h is 25, so that will be 0.025 multiplying big R for 4. The big R is 15, which is 0.075, and the small is 10, which is 0.005. So we have 0.005 0.075 power 4 minus 0.005 power 4, and this gives us, so we have 865, this is 52, 8650. 8650 times pi on 2 times 0.025 multiplying 0.0075 minus 0.005, and that gives us 8.62 times 10 power minus 7. Okay, so the total I is going to be 8.62 plus 4.05 plus 1.8 plus 8.85, all times 10 power minus 7. So we have 8.62 plus 4.05 plus 1.8 plus 8.85. So total I is 20 or 2.32 times 10 power minus 6 kilogram meter square. Total mass, so M1 will be rho pi h big R4 minus big R2, sorry, big R squared minus small r squared. So M1, so we have this, we have the big R, we have the small r. So yes, big R 17, so we have 1250 multiplying pi, the h was 10, 0.01 multiplying 0.017 power 2 minus 0.011 power 2 14 or 0.14, this is 10, okay, 0.14 here. So M1 is going to be 1250 multiplying pi multiplying 0.01 multiplying 0.017 squared minus 0.014 squared, and we have 0.0036 5, which is equal to 0.65 times 10 power negative 3 kilogram. M2, we have this, the H 0.04, we have 0.14, 0.11, so 0.004 0.014 squared minus 0.011 squared, and that gives us that will be 1.178 times 10 power negative 3 kilogram. M3, same, 1250 times pi, and the height 0.018, and then we have 0.011 squared minus 0.0075 squared, and that will be 0. So we have 4.576 times 10 power negative 3 kilogram. M4, we have 8650 times pi, the H 0.025, the R, you have the big R to be 0.0075, 0.0075 squared minus 0.005 squared, and that will be 8650 multiplying shift pi all on 0.025 multiplying 0.0075 squared minus 0.005 squared, and that is giving us 21.23 times 10 power negative 3 kilogram. So total mass, sum of mass, they have 3.65 plus 1.178 plus 4.576 plus 21.23 all times 10 power negative 3. So total mass, we have 3.65 plus 1.178 plus 4.576 plus 21.23, and that is 30.634 times 10 power negative 3. So your K will be square root of total I all over total mass, which is square root of our total I. We had 2.32 times 10 power negative 6, 2.32 times 10 power negative 6 all over 30 times 30.634 times 10 power negative 3, and this will be equal to the square root 2.32 times 10 power negative 6 all on 0.634 times 10 power negative 3, and that gives us 0.00870 meters, or 8.70 meters, or maybe 8.70, sorry, 8.70 millimeters. All right, so that is that for this question. That is that for this. Is there any question, or we should move on? Okay, so I understand you have a tough day tomorrow. All right, so I will consider pausing here, and then maybe the night before this paper we can continue so that the majority of you can benefit from whatever we can share. All right, so Badrick, thank you for sticking with me. I appreciate it so much. We'll link up later.